All right. So, looking at things we got going on today and this week. So, today is our last lecture. Don't cry, because then you'll make me cry, and then everybody in here will cry. So, save your tears for later. And if you're going to be cheering, definitely do that outside, no cheering. Your final exam is Friday at 8 a.m. unless you've made arrangements otherwise. And you did it. You got 48 out of 50 people to turn in their survey. So I will drop one extra quiz. And whoever you 2 people are who haven't filled it out yet, you're lucky. Everyone else picked up your slack. That's all. So, I have to have 1 or 2 things, a few videos to show about the end of this nuclear chemistry chapter. And then, if there are questions about the final exam review packet, I will be more than happy to answer those. If there aren't any questions, then we'll end early. Okay, sounds great. Okay, good. I thought it was a good plan also. Alright, so where we left off, we were talking about radiation in everyday life, natural radiation, places to get radiation poisoning, which is really hard to do, right? Because unless you're smoking lots and lots and lots of cigarettes every day, it's very hard to encounter that much radiation on an everyday occasion. Yes? Excellent question. Let's watch a video about it. Yeah, so I don't know if everybody remembers this. There was a KGB agent who was poisoned by radiation. It was maybe like 6 or 7 years ago. And so they just opened up an inquiry into who poisoned him, and he eventually died. And so this is a little news snippet about the inquiry that's going on.
The inquiry has begun to suggest Alexander Litvinenko, a former KGB spy who was killed by radiation poisoning in London just over 8 years ago. Litvinenko was arrested in Russia in the late 1990s for publicly accusing his superiors of assassinating a Russian oligarch before fleeing to London. After working as a journalist, writer and consultant for British intelligence services in the UK, Litvinenko drank a cup of tea laced with radioactive polonium-210 before passing away 22 days later in hospital. On his deathbed, Litvinenko publicly accused Vladimir Putin of ordering his assassination, a claim Russia has formally denied.
Alright, so that's radiation poisoning in the news. Hold on, cancel. And what does it look like to get radiation poisoning?
Hey there, I'm Josh Clark, and this is Brain Stuff, and this is the Brain Stuff where I explain to you how radiation sickness works. So, unless you work around nuclear activity or an enemy of the Russian state, you probably don't have much to worry about as far as exposure to radiation goes. But there are situations where you could be exposed to harmful doses, like a nuclear meltdown, a nuclear explosion, even the medical equipment leaking could expose you to a harmful dose of radiation.
Yeah, if there's nuclear explosion, we have worse things to worry about.
So here we go. Not to freak everyone out, but radiation is everywhere all the time, and we're exposed to it on a constant basis, something that's called background radiation. Perfectly fine, don't worry about that. But when we're talking about human exposure to radiation, we're talking about something that's measured in what are called sieverts. And sieverts take into account not just how much radiation you've been exposed to, but how much radiation you've been exposed to over time, say a year, the intensity of the radiation, and the type of radiation we were exposed to. So for example, there's alpha particles. These are low-energy radioactive particles that actually are deflected off of our clothing. The problem is we can still ingest them, and they can do terrible things to it, like cause lung cancer and the like. Beta particles are a little more energetic, and they're actually smaller than the alpha particles, about 8,000 times smaller. And they can actually penetrate our skin, which can create a lot of problems for us as well. But the big daddies are called gamma rays. They're not even particles, they're rays, and they come at you big time with high energy and mess you up. Like I said, we're exposed to background radiation all the time, but it's not much to worry about. In fact, the average background radiation a person's exposed to is something like 0.0036 sieverts. which isn't a very big amount, especially considering that the average CT scan exposes a human being to something like 0.01 sieverts. The thing is, federal guidelines say that we shouldn't be exposed to more than 0.05 sieverts within a year, and it's not a big leap from that to the radiation sickness rate that begins at 0.75 sieverts. And remember, when we're talking radiation sickness, we're saying cumulative amounts. So when this stuff starts to build up, you start to get sick. Between 3 sieverts and 10 sieverts of exposure gives you about a 50% chance of dying within 30 days. This will come after your hair falls out, you're racked with nausea, and you start to form scars beneath your skin. Perhaps the worst thing about radiation sickness is that when you first show symptoms, they only last for 1 to 2 days, and then you appear to be getting better. But you've actually entered what's called the latency period, where your body is getting worse and worse and worse as you get sicker and sicker and sicker. And after, say, something like 30 days, you're in big trouble. So what can you do to protect yourself from radiation sickness? Well, wearing a lead suit around everywhere all the time is probably impractical, but there are some steps you can take in the real world that will keep you safe. And number one amongst them is stay away from radiation. If there's a radiation leak around your house, experts say that you should go into a windowless room and basically hide there until you run out of food or somebody comes to get you. And of course, everybody, if you want to know at home whether or not you've been exposed to enough sieverts to make you sick, just look for the healthy green glow. It's a big giveaway. So let us know. Have you ever been exposed to radiation sickness? Leave a note in the comments. We'd love to hear from you. And while you're down there, why not just subscribe?
Okay. So it's kind of like having the worst version of chemotherapy, where your hair falls out, your teeth falls out, like because it's killing off all your cells, they're not able to replicate. So you end up having like a slow-ish quick death. I mean, 30 days. I mean, it's not the slowest death, right? But not super speedy. So the Russian spy drank polonium in his tea, but didn't realize he was sick till 30 days after. Like, he got nausea, heartburn. He thought, that's weird. But then he got better. So by the time his hair fell out, he was vomiting blood, it was too late. And so they are opening up an inquiry as to whether or not Vladimir Putin actually got the hit on him. The dosage and how they're injecting it. And so chemotherapy is chemical treatment, which is not the same as radiation therapy. And so chemotherapy is not radioactive. That's a separate set of things. But chemotherapy, the trick is that when you ingest it, or they inject it, it's going to kill off any fast-growing cell, regardless. You can't tell it's health or not. And so your hair is considered faster growing than some other types of cells. That's often why hair starts to fall out and things like that, Tori. So a lot of the symptoms that you see is because chemotherapy kills everything that's fast growing. And so hair fallout, nausea, things like that, because it can't tell the difference between a cancer cell and not a cancer cell. They could have done some things to help, like maybe a blood transfusion to try and get it out of his system. It'd probably go on dialysis to try and flush out the kidneys. So they could have done some preventative steps to at least expand his life, but it's unclear exactly how much he took. And so radiation poisoning is a hard thing to undo because it kills the cell's DNA. And so, unlike heavy metal poisoning, that's reversible if you catch it soon. But radiation poisoning is harder to undo. Alright. Let's talk about good things you can do with radiation. As soon as I find my sheet, here we go, uses in medicine. We use radiation in medicine quite a bit, besides the PET scans we talked about. The next most common one is this iodine-131. So, for those of you who have taken a little bit of biology, the thyroid is where iodine is taken into your system to then process it and send it back out. If you're having thyroid issues, they will give you a dose of radioactive iodine, which, if your thyroid's acting normally, some will accumulate in your thyroid, and they'll be able to do a PET scan of it. Be like, oh, it looks like the right amount. If your thyroid is overactive or underactive, it won't have the right amount of iodine in it. And so they can then tell which way it is, over or underactive, and then start a treatment for that. If it's thyroid cancer, then it means it's using up the iodine really, really, really fast. And so that's another sign that they should probably start some sort of treatment for it. So, another fun fact with I-131. Item 131 is made the cyclotron at Oak Ridge National Lab. One of the things they do is they make medical iodine. Let's see what else is on here. Right, so the PET scans of heart and brain, you're going to use a radioactive fluorine molecule. So the same thing, it's an injectable fluorine that's going to end up in the heart or the brain, depending on what part of the body they're looking at. Let's see what else. Oh. Oh, okay, just out of order. There we go. A cancer treatment that uses a radiation method is called IMRT, imaging radiation therapy. And this is a focused beam of, I think, gamma rays that can then be used to specifically target cancers. Right, so chemotherapy kills off everything. You can use radiation to specifically target cancerous bodies in your body if you know where they are. So let's look at how that works. You probably do. Mm-hmm.
Your doctor may recommend intensity-modulated radiation therapy, a procedure that treats certain forms of cancer to kill cancer cells or control their growth. The cells in the body grow and divide as part of the normal cell cycle. The cell's nucleus controls this process. Inside each nucleus, genetic material called DNA contains the instructions for directing this process. Sometimes the cell's DNA becomes damaged. Normally, the DNA responds by either repairing itself or instructing the cell to die. In cancer, however, the parts of the cell's DNA that direct cell division become damaged. When these sections are damaged, the DNA is unable to repair itself. Instead, the unrepaired DNA causes the cell to grow and divide uncontrollably into more damaged cells called cancer cells. A tumor forms as the cancer cells multiply and displace the normal cells. Radiation kills cancer cells by inflicting overwhelming damage to their DNA. The tumor shrinks as the cells stop dividing and die. If the tumor is in your head, your radiation therapist may make a mesh frame or mask that will keep you positioned correctly during the IMRT. or you will get small permanent tattoos to help align the IMRT. Next, your therapist will do a CT scan of your head to get a detailed picture of your tumor and its borders. Your doctor will use the scan to specify the three-dimensional shape of your tumor and vital tissues nearby. The tumor's shape, size, type, and location help your doctor determine how the IMRT beam should be adjusted to hit your tumor and avoid healthy tissue. During your procedure, a medical linear accelerator will deliver an X-ray beam to your tumor. A computer inside the accelerator will adjust the beam with a device called a collimator. The collimator will adjust or modulate the intensity, direction, and shape of the radiation beam. This feature allows higher doses of radiation to be delivered to your tumor while sparing your healthy tissue around it. You may receive many radiation treatments over days or weeks. This allows your body to recover between treatments and to kill as many cancer cells as possible. Side effects are usually mild and occur only in the treatment area. Common side effects include localized skin irritation, localized hair loss, or inflammation and swelling near the tumor location.
Question, Chris. They could do it in other parts of the body, but it's more often done in the brain because it's harder to do surgeries there, right? So a lot of times what they'll do is they'll pair a surgery with a cancer treatment, try and excise, especially if the mass is large, try to excise as much as they can first, and then treat whatever they can't see with some either chemo or radiation. But if you have a brain tumor, it's pretty extreme to go in there and try and cut it out because you end up with all these other crazy side effects. And so they'll try and do the radiation therapy first, if they can at least shrink it. Your body can try and reabsorb it or anything else. That's the plan, right? Hopefully have it totally go away. Because the other tricky thing about cancer cells is that when they talk about metastasizing, it's because those little cancer cells jump into your bloodstream and they travel someplace else. The next thing you know, like you had liver cancer, but that extra little bit of cancer cells jumped in your bloodstream and traveled up to your lungs. Well, now they're starting to grow there, and then they'll travel someplace else. And so the key is to try and catch them before they break loose from the big mass and travel someplace else in the body. Which is why often chemotherapy is used, because it kills everywhere in the body all at once. Heavy downer yet again. Alright, that was everything I had about fun uses for radiation. Fun facts. Does anyone... Tori. Oh, yes. Yes, so if you've had radioactive dye injected in your arm, which burns like a son of a gun, then, yes, that's the one. Because, I don't know what they put in there besides that, but it hurts. It could also be the gauge of the needle. Big gauge needle. No, it's into your arm. You just let it kind of make its way up there. Sometimes you'll have a contrast scan, and it's octopus dye. If you have a contrast scan, it's octopus dye fluoresces under an MRI. So that also burns. Burny, burny, burny. Does anyone have anything they want to ask about the final? No, this one is specifically only over 109 material. It's called the second term Gen Chem exam, so it only covers 109. Yeah, still curves, yeah. 40 points. The average was a 35 out of 70. It's 70 questions, you get 2 hours to do it. That was right. So I'm saying, like, that was a 50%, but that's not the percentile, right? So that's how many questions you got right. 35 out of 70 is actually like the 70th percentile, and so that's why it works out, right? Because the average should be around C plus in theory, and so if you get 50% of the questions right, it's like any other standard exam, right? When you take the ACTs, there's how many you got right, and there's how many you got right compared to the entire nation. Yeah, so it's tricky to do it either way. What I try to do is whatever the lowest score points, so like number right, whatever the lowest number right is, that's going to be the lowest grade. That's going to be like a 62 or 63. And then whoever got the most points right, I think last year was like 50 out of 70. That person got 100. And then I use a sliding scale to try and match it up so that everybody falls in between that range. So it's tricky. Chris. All multiple choice. Mila. Yes. Yep, and I take that into account. Like, there's stuff we just didn't, well, I mean, we got to everything, but some other professors put focus on things that aren't in our textbook, right? So it depends how much textbook you use, what stuff's on it. So there was going to be like a question or two about organic nomenclature. I don't expect you to know that. If you do, great. If you don't, I can't penalize you that because I didn't teach that. So that's part of the curve that I take that into account. So I would say do the final exam practice that's on my website, because that's the style of questioning, and mostly go back and practice multiple choice questions, because it's all multiple choice, right? So you have to be able to go in, and it's great if you can calculate it, but most of the questions don't require a lot of calculations. Most of them are, okay, if given, do I have a copy of it? Not in yet. Alright, so this is the one that's on my website, right? So here's the solubility. What's its solubility product constant? Right? Quick calculation. You don't even have to do an ice chart. It should be barium fluoride. So square root of that. Done. Right? Or, like this one has no calculations at all. It's asking about Avogadro or Le Chatelier's. If I have a yellow and a colorless solution added together to make red, what happens when I add silver? Or what happens when I add more iron? Or what happens when I add more thiocyanate? Right? Which way does it shift? And then based on the shift, what color is the solution? Right? No calculations at all in that question. Nothing in this section has calculations. Right? So there's very few calculations. There's a lot of quick conceptual questions, right? If you have a positive H and a negative S, what does that tell you about its spontaneity? Non-spontaneous all the time, so which is the correct K? Less than 1. Done. Move on to the next question. Right? So a lot of it is just like remembering the thing. You could certainly have calculated for that. So most of it you don't need your calculator for. It's more just thinking through the concepts and then making a good answer. So. Will I what? No, bring your own calculator. Yeah. Unless it's scientific. If it's the one that's graphing. The graphing calculator, you can't use it. It has to be a non-graphing calculator based on the rules of the ACS. It has to be a non-graphing scientific calculator. I can tell you, let's see, where is mine? I was giving away too many secrets. This is not the one you're going to use, but I can at least show you, right? So the front page says, do not copy. Good. We use a new version of it, so it's only 75 questions, I think. But non-programmable calculators are permitted. It is obviously old. They wouldn't have a PDA? No, you probably don't. I think the new version says cell phones from 2002. And on the second page, you get all of this information. All this stuff is given. This is what they give you. So they give you some constants, give you an abbreviation, and give you a periodic table. You're on your way. No equations. It is everything that you're given. Which is why all year I don't give you equations, because I don't want you to use them as a crutch and then I yank them away on the final. Yeah, I could leave them on the board, but then I would be in trouble. Yeah. Yeah. Alright, any other questions about the final? Most people finish in 90 minutes. Like, you get 2 hours, but the majority of the people will be done in 90 minutes. You are more than welcome to stay the whole 2 hours. I'm not going to kick you out, but... I would fall on my chair, firstly. I've never seen that happen. But if that happened, then I would have to change the scale, because that would be an outlier. So... Or they cheated. I mean, to be honest. If they did that well. I'm going to... Maybe they are an amazing test taker, but that does seem unlikely. So, alright, go team chemistry. Yay!